modernization, why we need that, how we're going to get it, and also I want to talk about the Optane technology. I represent Intel and our new memory things, SSDs that we call Optane, 3D Crosspoint. Have you ever heard about it? Well, we have been working with HPE, Microsoft, Intel, developing that technology for Microsoft SQL. So we do have interesting facts to talk about, but mainly talk about the technology. Since it's so new, we need to take some steps and analyze how we are going to use that. That's the main focus today. But also, we need to talk about why we need to modernize our hardware. And lots of people talk about hybrid, and we realize that people are going to be on premises for a long time, and they will transition to the cloud. No things, we'll start in the cloud and we'll decide, do we need to stay in the cloud? Can I stay in the cloud and go back to on-premise? But there's no 100% in the cloud or on-premise. We're going to be hybrid, and hybrid is the right answer for everything, I guess. So by delaying your modernization, you start getting into technical debt, your data security. You don't have a good hybrid story because your hardware and software is lacking all the features to actually take advantage of cloud and hybrid. Some numbers here is why we need to modernize IT budgets, staff, unplanned downtime. So the more you delay, the more likely you incur on those things. Obviously, we're talking Intel, HP, Microsoft. We always want you to get the latest and greatest, and that's our job to make sure you are comfortable getting the latest and greatest. Data security compliance, very, very important today. The longer you delay, your security patches might not be available for you once you hit that end of life for software and end of life hardware. So you need to realize that hardware and software do have their own shares of security threats, and we need to make sure that we are all protected against it. And one of the points is to be up to date. One path for monetization, you see a lot of HCI. Microsoft announced Azure Stack, Azure Stack Hub, Azure Stack Edge, Azure Stack HCI, the Azure Stack family. And for me, HCI, we are on-prem, and Optane has a major play on HCI solutions. We do love to be in cache as Optane and NVMe. We have a good value prop for increasing memory and dense nodes. So that's what we're going to start talking about. Expand your workloads and DevOps. Without new software, you might not be able to take advantage of new software development and how we improve our software deployments, how we improve our IT, because we are so much stuck on how IT has been running for 10, 20 years. And with this new idea of DevOps that you need to be faster, fail fast, it takes a change in perspective. And that change in perspective will bring also new software, new hardware that will need to be the base for that DevOps experience. Obviously, we're end of support on Windows. We have seen several sessions around this week about the end of the life, end of support. It means that you're not going to get security updates, and if you need to stay there, you're going to pay more. So that's the right time to realize to move away from old legacy software, and in this case, old legacy hardware at the same time. Because running a new software on hardware, you'll not take advantage of the whole features of that the new software can take advantage. For instance, compression, SCJX for Intel, or even more cores. So new softwares are enhanced to use cores, use NUMA nodes to address memory more. But if you stuck on old hardware, old servers, you are not taking advantage of that. So you improve your software, but you don't get your money's back worth, because software licensing is one big cost of your IT infrastructure. So make sure that the money you pay for software is backed up by a new hardware, so you actually take full advantage of that. Like I was saying, the point is you have a balanced solution and a balanced approach. You need to update your memory, your compute, your networking, and your storage. And Intel has provided that on all aspects. So obviously we're talking about our Museum second generation, our Optane NVDIMMs, our Optane SSDs, and our all-flash solutions with NVMe and our new networking. So we are ready to take advantage of all that. And it's all Intel, all HP, and now Microsoft. So we work closely together to make sure that everything works as perfect as possible. So we bring improvements on all points of your architecture. So when you're designing a solution, you need to think about all those four corners on the hardware side. Because if you increase your number of cores, but you don't increase your storage performance or your network bandwidth on a distributed system, you will hit one of those bottlenecks. Or you increase your memory, but don't increase your compute power. You won't be able to run as many VMs as you need. You add more storage, but if you add only storage capacity, you think of all the hard disk drives. You need to add so many of those in order to take advantage of little performance improvement. Maybe it's time to go all flash, NVMe, use Optane as cache in order to balance your compute power with your storage power. Networking, the same point. If using HCI, using distributed systems, using container, you will have a distributed system. If you don't take advantage of your networking, or your networking is your bottleneck, doesn't matter how much compute power or performance on the storage power you have, you want to be able to take advantage of it. So everything is going to be interconnected. So when I do designs for HCI, which is what I normally do, I need to take care of all those things. And I need to have the input for the customers saying, what do you need? What's your trade-off points? Because everything is going to be a trade-off. If you have enough money or no limit credit cards, you just put the best in everything and you'll be fine. But that's not the case for everybody. We need to realize what's the trade-off that we have here. And you can see on the HP booth, we have a SQL demo with Optane persistent memory, where we're changing some of the storage parts. So instead of hosting SQL on regular storage, we are hosting SQL on the persistent memory DIMMs. So you're changing your credit on storage and put your credit on memory, on persistent memory. And that you get your increase in performance, and you don't spend on flash storage, you spend on memory storage today. So that's one of the trade-offs that we can talk about. Some numbers of how much does it cost to run old hardware against new hardware. So the more you delay your change or your upgrade, you end up in more and more cost. So that's kind of the idea that we want to pass to you. Make sure that you are getting the most of your hardware and software, but at the same time, you are aware that the longer you delay some upgrades, you may be incurring penalties and financial penalties. So, along with the new DevOps cycle, you can take advantage of everything that is coming, and at the same time make sure that your IT is covered by security, compliance, and everything that comes along. So I mentioned all our core engineering efforts with Microsoft and Intel. So let's talk about our new Optane. So here's just what's the difference, or what has been added on each operating system on each one of the categories, like hyper-converged, software-defined storage, servers, those kind of. So let's move to SQL 2019. Have you heard the announcement that Microsoft is launching SQL 2019? We have BDCs with the big data clusters, and for Intel is the first database from Microsoft that fully takes advantage of Optane technology. So it will be able to work on storage mode and memory mode and persistent memory mode. And obviously for Microsoft, they added all those topics. So let's talk about Optane and what is this new technology. So Optane is based on what's called a 3D cross-point media. So it's a new media that has been developed for many years by Intel and by Micron as well. But now we are split away, so we have our own fabs. So this new technology, those new memory flash, is very unique because it has the characteristics of both storage and memory at the same time. So if you compare with regular SSDs or regular flash that you have today, it's bit addressable. So I can change data on a bit level on that memory. So I don't need to change on an array of a page or a block like on regular SSDs that we have today. So that gives me a much larger advantage on performance, and also a much larger advantage on endurance, because I don't have to be cleaning up wasteful pages if I do changes on a smaller size. For instance, normal SSDs, they have a page size of 1 megabyte, 2 megabytes, and a granularity of 4K. So if I'm not aligned to those boundaries, every time I go over those boundaries, I will need to refresh the media and make sure I organize correctly. So with Optane, I'm not bound to those limits, so because I can change individually each page. Along with Intel IP, we developed two products out of it, which is the Optane DC persistent memory, which is the thin form factor, and the Optane NVMe SSD. The SSD is basically what it says. It's an SSD. It does not have the persistent memory features. It has just the storage features. The thin form factor, then you have both. It can be used as a storage and also can be used as persistent memory plus memory. So it gives you the advantage to choose whatever you want in these three topics. So if I need a node that is higher in memory capacity, I can get all the DIMM capacity and present as regular memory to the server. So it's not going to be in the persistent form. Or I want to store my database on the DIMMs. In this case, this is not going to add memory for you, but it's going to use storage capacity in a persistent fashion. So in this case, what happens is when I sit a file system on top of that persistent memory, I will say to the file system, this is a direct access file system. What means that every single data that is stored there is memory mapped. So I will not go to the file system, the I/O manager, partition manager, volume manager, disk driver to get to the data. The data basically is readily accessible by the application as a memory mapped data. So that gives you a great advantage in performance, but also tells you the application needs to be ready to do that. Because normally what we do, we just do a read-write operation, called the read-write APIs, and we go over the I/O stack. Also, if the application is not ready, you can just use the DIMM capacity as regular block storage. So the application just, okay, it's a disk, and I'm going to use that. So the applications for that, it is interesting because you could, on the HCI solution, you could take a small part of the persistent memory and say, this is a cache, using as a block device cache. And the rest use as a memory augmentation or memory replacement. So you have that choice. And both modes can be used at the same time. And also I could use an Optane SSD in the PCI slots. The only point is the CPMM works with our Xeon second generation scalable processors. So that's the CPU of choice that you have to be, because there's a special memory controller and everything that comes along with that. So when talking about Microsoft SQL, there are those ways to use Optane persistent memory. First one, here, what we call hybrid buffer pool. That's going to be for SQL 2019 on Windows. This is basically saying that a particular database, it is on a PMAN, on a persistent memory fashion, right? And in this case, we would just alter the database and say this database is memory optimized. Second point, which is you're going to see on the HP booth, it's Enlighten IO, which is Microsoft SQL 2019 on Linux. In this case, I just create a file system, XT4 or DFS, and direct access. And if you don't have SQL 2019, you still could use persistent log buffer or tail the log, or block device. Just place your database on that block device. So the whole idea of Optane is actually bring the data closer to the CPU, to bring the data to your application as fast as you can on a normal, and that's about it.